Welcome. In this review, we're taking a hard look at the systemic risks embedded within engineering calculation workflows. Our analysis is grounded in recent market studies that have identified some critical and often overlooked challenges that impact business continuity, legal liability, and your competitive edge. So let's start with a question. Does this scenario feel familiar? It's a central paradox we see in modern engineering. Firms are investing millions in incredibly advanced digital modeling, but the actual calculations that form the bedrock of those models, they often live in scattered, outdated, and frankly, high-risk spreadsheets. This disconnect is a huge and often unacknowledged source of business vulnerability. Here's how we're going to break this down. First, we'll clearly define this engineering paradox. Then, we'll dive into 5 systemic risks that spring from it. After that, we'll look at the real business impact, propose a framework for building more resilient systems, and wrap up with a strategic view on what it takes to future-proof your firm. Okay, so what is this paradox exactly? Well, at its core, it's a massive gap. On one end, you have simple tools that just aren't powerful enough. On the other, you have large-scale, expensive software that's often inflexible or just plain overkill. And it's right inside this uncontrolled gap that errors are born, that invaluable company knowledge gets lost, and where business development can grind to a halt. This leads us directly to the 5 primary challenges that translate into serious business risks. Really understanding these is the critical first step. It's how you begin to mitigate them and ultimately turn a major vulnerability into a real strategic advantage. The first risk is a crisis of transparency. You see, engineers are often caught between 2 bad options. On one side, you have the black box of complex software. It gives you an answer, but you can't see the process, forcing a kind of blind trust. On the other side is the black hole of spreadsheets, which creates this illusion of control but actually hides the calculation logic in a tangled mess of cell references that's almost impossible to truly audit. And the consequences here are tangible, and they are severe. As you can see from this table, simple mistakes can lead to critical failures. Logic errors create a false sense of security. Hard coding means you're using old values when parameters change. And unit errors, mixing up millimeters and meters can throw off a load capacity by a factor of 1,000. That's the kind of thing that risks catastrophic failure. Now for the second systemic risk, the privatization of your company's knowledge. When your most critical calculation methods only exist inside an individual's personalized files, your expertise is not a scalable asset. It is a key person dependency, and that's a very precarious position to be in. This dependency creates a vicious cycle of rework. A senior engineer develops their own amazing spreadsheets. Then they leave the company. What are you left with? An unusable archive that no one else can decipher. So the new person has to start from scratch, reinventing the wheel. This cycle completely undermines business continuity and makes it impossible to build up institutional expertise. The third risk is all about a lack of operational agility. Those heavy, one-size-fits-all software platforms, well, they're inherently slow to adapt. If you need to work with specific national standards or local codes, they can become a major bottleneck for your project teams. When you depend on a vendor's update cycle, your firm's ability to respond to regulatory changes is completely out of your hands. On top of that, the high costs and the inability to customize these tools for routine tasks just leads to an inefficient use of both your capital and your engineer's time. This fourth risk happens during the documentation phase. We call it the dead data problem. Just think about it. The moment a number or a diagram is copied from a calculation into a report, that link to the source is gone. It's severed. The data becomes static and, worse, unreliable. And the scale of this problem is huge. Up to 40% of mechanical errors in final documentation are introduced during this manual data transfer. So every time a project changes, someone has to go on a manual hunt for all that related dead data. It's an inefficient process that is just begging for errors to be made. The fifth and final risk we'll cover gets right to the heart of verification and its direct impact on your legal exposure. Because if there's ever a dispute or a failure, the defensibility of your calculations is absolutely paramount. The contrast here is stark. Certified software gives you a defensible third-party validation of your methodology. A proprietary, homegrown spreadsheet, it offers no such protection. It lacks any formal validation, which places the full weight of liability directly on the company and on the engineer who signed the project. So, when you add all of this up, what is the cumulative business impact of these 5 risks? Well, it's much, much bigger than just the cost of correcting a few mistakes. The true costs show up as damage to your company's reputation, as project delays from constant rework, and as that heightened legal exposure. But maybe even more strategically, these risks lead to a stagnant corporate knowledge base and the misapplication of your most valuable asset, the time and expertise of your senior engineers. All right, we've defined the risks. Now let's pivot to the solution. The goal isn't just to mitigate these problems, it's to establish a framework that actually creates a durable strategic advantage for your firm. The foundation of this kind of framework is what we call the glass box concept. This is the direct antidote to the black box and black hole problems. In a glass box system, the calculation logic isn't hidden away. It's an integral, visible part of the document itself, making the whole thing completely transparent and auditable. So a resilient system like this is really defined by 4 key hallmarks. It's transparent and auditable by design. It's flexible, which empowers your teams to create their own validated tools. It ensures reliability through a shared knowledge base, and it achieves integration, creating live documents that finally eliminate the problem of dead data. Adopting this kind of framework is so much more than a simple change in tools. It really represents a fundamental evolution in your engineering culture and in the strategic positioning of the firm itself. This quote from the source material really captures the essence of this transformation. The future value of an engineering firm won't just be in the expertise of its individuals, but in its proprietary, scalable library of automated and verified solutions. This shift calls for a new kind of role, the digital engineer. This is a specialist whose value isn't measured by performing routine calculations, but by their ability to design, build, and manage the automated systems that perform those calculations reliably and repeatedly. But remember, technology is only the enabler. To truly realize this future, it all comes down to a cultural commitment. Transparent, scalable, and high-quality documentation can't just be an exception. It has to become the ingrained standard for every single project. So we'll leave you with this final question to consider. As you look at your own operations, you have to determine whether your firm's most critical intellectual property is a scalable corporate asset, or if it's still a significant, unmitigated dependency on a few key individuals. The answer to that question will define your firm's resilience and its readiness for the future.